Something else we have to consider when naming ionic compounds is whether or not that compound contains any polyatomic ions. So what is a polyatomic ion? Let's look at the name. Poly means many. Atomic meaning with atoms. So a polyatomic ion is an ion that contains many atoms or more than one atom. So for example, a common polyatomic ion that you're going to see a lot in this class is NO3. And that has a minus charge. And the name of this is nitrate. So the way that this would show up in an ionic compound, for example, it's in a compound that looks like this, KNO3. So this would be potassium nitrate. And it's made up of a K plus and that NO3 minus. So notice that this still obeys the rule of ionic compounds in that the plus and the minus charges equal each other, so they balance each other out. So I'm going to give you a list of polyatomic ions that you need to memorize for this class, except I'm only going to give you the formula. I'm not going to give you the name. And that's because it's actually going to help you learn them and memorize them quicker if you have to go through the motions of actually looking them up for yourself. So these are the ones I want you to memorize. So you need to know these formulas with their names, and I want you to look up the names. So we have NH4 plus, notice that one's a cation. And then the rest of the ones I want you to memorize are anions. OH minus, CN minus, MnO4 minus, ClO3 minus, CH3COO minus. Another way that you might see that written is C2H3O2 minus. So just recognize that as the same thing. CO3 2 minus, SO4 2 minus, and PO4 3 minus. So again, these are all the ones I want you to memorize, and I want you to look up the names. You need to be able to match the names with the formulas so that you can name ionic compounds when they contain polyatomic ions. Notice that a lot of these polyatomic ions contain oxygen atoms. So these are what we call oxyanions. So these are a special type of polyatomic ion, and they have and these are anions that contain oxygen. Not necessarily one oxygen, they might have one, or they might have two or three or more oxygen atoms, but again, they're just anions containing oxygen. And the way that we name oxyanions depends on the number of oxygens that it has. So there are two main suffixes that we use when we're naming oxyanions. And the first one is ITE, and we also use ATE. So notice that for oxyanions, we don't use the IDE ending, we use either ITE or ATE. And so what's the difference? ITE basically just means that it has fewer oxygens. So we use ITE for the oxyanions that have fewer oxygens, and ATE if it has more oxygens. So what constitutes fewer or more? That depends on exactly what that oxyanion is and like what family of oxyanions it comes from. So for example, if we have NO2 minus versus NO3 minus, we already talked about NO3 minus. We already identified that as nitrate in the previous slide. So notice NO2 minus, it has one fewer oxygen atom than NO3. So that one is going to be nitrite. But what if there are like even more, even fewer oxygen atoms in these polyatomic ions? So this is where we are going to add some prefixes. So we might have hypo plus the base plus ITE. And that is going to be less than whichever one has fewer. So I like to call that less than the lesser. And then we have our ITE, which just means less, ATE meaning more. And then if we have even more, then we'll have per plus the root plus ATE. And I like to call that more than more. So I'm going to give you some examples because this is kind of hard to picture without really having anything to relate this to. So there's a whole series of oxyanions, ClO minus, ClO2 minus, ClO3 minus, and ClO4 minus. So if we use our naming conventions, then that is going to be hypo, chlor, remember that's our base for chlorine, ite, and then we just have chlorite, and then chlorate, and perchlorate. So it's really helpful whenever you have a series of polyatomic anions, or a series of oxyanions, excuse me, that you know the name of at least one of them. So you'll probably notice if we go back to our little chart here, I'm asking you that you memorize this one here. And does that look familiar? It should. That is our chlorate. So notice that if you know chlorate, then you can also figure out all of these three because you can compare the number of oxygen atoms in each oxyanion.